Hey guys, welcome to our calculus topics video for calculus purposes. I'm David.
I'm Sonya. And these are our top 10 calculus topics.
Go. Coming in at number 10 is related rates. Related rates problems are problems with two variables that change at the same time at different rates.
For example, as Nevan gets farther away from the lamppost, the length of his shadow increases.
In a limit as x approaches the value, some function f of x will approach a y value. So in this case, as we approach the stop sign, our function car of x is closer to Nevan.
I'm gonna stop, you're gonna read the limit!
Oh my god, it's that Nevan! We have to save him.
I don't think we can, he's a lost clause.
Hold on, what are you listening to?
Mean Value Theorem Remix by Madame McDowell. What a banger.
What's up everyone, Sakhan here. Today we'll be talking about the corollary to the FTC. As long as f is continuous on 8b, you can do this little procedure here. Basically I think of it like you're just switching the x. If it's like x squared, make sure you take the chain rule as well. But let's say you have a banana, right, and it's peeled. So like peeling it, well, not peeling it, but taking the integral is like, that's black. Taking the integral is like putting the peel back on, okay? But then taking the derivative is like peeling it again, so you just left with the banana.
One way to approximate the area under a curve is using Riemann sums. Riemann sums fit rectangles of varying sizes under the curve. We can calculate the area of each rectangle and add them all up to find the area under a curve.
What are you doing?
I'm trying to approximate the area around your big head with rectangles.
When we try to evaluate limits and we get an indeterminate answer, we can simply use L'Hopital's rule. Simply take the derivative of both the numerator and the denominator and evaluate the limit again.
You want a popsicle?
No, I'm good. The limit doesn't exist.
He doesn't know I can use L'Hopital's rule. What about now? So you have position, right? Take the derivative, you get velocity. Take the derivative of that, you get acceleration. Also, if you take the integral of velocity, you get displacement. Check this out, though.
So when you have a function with bounds and you revolve it around the line, you get a solid. And you can calculate the volume of the solid with integrals, either through the washer method or the disk method.
Well, welcome to Popeyes. How can I help you guys today?
Can I just have a small shake? Can I also have all of your life savings?
No.
Okay. Now do a little spin. Not enough volume.
A revolution does not produce sufficient volume.
When you're looking for the integral of a function, you are performing the inverse process of differentiation.
David, do you hear that?
Oh my god, what's going on?
Shh. Oh my god.
Oh my god. What's she doing?
Nevan, is that you? When you are trying to take the derivative of a composite function, you multiply the derivative of the outermost function by the remaining parts of the function. You repeat this until you get to the last function. Whoa, man, what is that?
I like to call this the chain rule because You know, it has multiple functions inside of each other. Look, you have the first, then the second, third, and then there's this last one. Isn't that so cool?
Yeah, it is.
Yeah, man.
Alright everyone, thanks for watching.
Hope you all enjoyed that video.
And we'll see y'all later.